Hello and welcome to this lesson on trends in Group 1. In today's lesson, we will firstly understand how the properties of the alkali metals depend on the outer shell of electrons. Secondly, we will predict the properties of alkali metals based on trends observed down the group. The properties of elements in Group 1 of the periodic table depend on the configuration of electrons in their outermost energy level, also known as the valence shell. Here, we will explore how the properties of alkali metals are influenced by their outer electron configuration and observe trends down the group. All alkali metals, which include lithium, sodium, potassium, rubidium, caesium, and francium, have one electron in their outermost energy level. This lone valence electron is important because it is easily lost in chemical reactions, allowing these metals to form stable +1 cations, which are positively charged ions. The ease with which this electron is lost accounts for the high reactivity of alkali metals. As we move down Group 1, we observe several trends in physical and chemical properties, directly linked to the increasing atomic size. The reactivity of alkali metals increases down the group. Lithium is the least reactive, while francium, when observed, is the most reactive. This trend is due to the increasing atomic size. As the atoms get larger, the outer electron is further from the nucleus and is more easily lost, due to the weaker attraction to the nucleus. The melting and boiling points of alkali metals decrease down the group. Lithium has the highest melting and boiling points, while caesium has the lowest. This is because the larger atomic size reduces the strength of the metallic bonds, which are electrostatic forces between the positively charged metal ions and the free electrons. We will delve into this in a later unit. Density generally increases down the group. Lithium, sodium, and potassium are less dense than water, and thus they float on water. This is due to the increase in atomic mass as you go down the group. To visualize these trends, consider a graph. On this graph, plot the atomic radius for each alkali metal. Notice how the size of lithium is much smaller compared to caesium. Understanding the properties of alkali metals within Group 1 shows how the arrangement of electrons in the outermost shell influences their behavior. By observing the trends down the group, you can predict properties for the alkali metals, making connections between their atomic structure and their physical and chemical characteristics. In today's lesson, we delved into the properties of the alkali metals and how these properties are influenced by the outer shell of electrons. We began by identifying the alkali metals as Group 1 elements on the periodic table, which include lithium, sodium, potassium, rubidium, caesium, and francium. The reactivity of these metals increases as we move down the group from lithium to francium. This trend is due to the increasing atomic size, which makes it easier for these metals to lose their outer electrons. Additionally, we examined other trends observed down the group, such as decreasing melting and boiling points and increasing density. These trends were linked to the atomic structure of the Group 1 metals. By understanding these patterns, we can predict the properties of alkali metals not yet encountered in experiments. See you next lesson.